Ho, ho, ho. Welcome to day number 21. We are only 3 days away from the 24th. And today's room on Advent of Cyber here on TryHackMe is going to be about reverse engineering. Now, I started up my program and I have my Windows, the VMware is now opened. And we do have some things we need to take care of. There's the binary file there and a PEStudio and a demo that we can go ahead and check out. And something called ILSpy. Those are probably the programs we're going to use for this reverse engineering day. And they are probably wanting us to investigate some, I don't know if you're going to investigate your WannaCry. This is the WannaCry ransomware. But in a computer, talking about binaries, that's basically just a source code, code, something you write, programming code, right at that. You compile. When you compile that is being translated to binary form. What are you going to call that, and save it as a binary. Now, a binary file is... It's just, a form of structure of code that can be executed on a particular operating system. Also, it needs to be compiled to a specific, instruction set, which is the architecture of the actual, CPU. You probably heard about AMD and Intel, for example. So, disassembly versus decompiling. When you are decompiling something, you are essentially trying to get the code back, when you are as to the form where it was, what it was, that's in most occasions not possible. But a disassembly is another thing where you just basically take the binary file inside some sort of editor like this, and what you see is what you have here on the other hand. That is called assembly code. So you will see all the different functions and instructions written. What is essentially what source code is compiled to, but this is not binary. This is just a step that is really close to binary code, but it is not exactly binary code. I've been playing around with IDA Pro a couple of times. Ghidra is really good also, and GDB is also really good to do this. I have been playing around with disassembling some stuff for some computer games at some point. I wanted to learn how it worked and, create some, client-side, layers and stuff so you can interact with the server and so on. Well, and this is something you shouldn't never do unless you understand that there's a slight chance that the company might ban your account. So, anyways, there was disassembly, decompiling as before. It converts, into high-level code just like this, as I told you before. It will try and revert the code from binary back to some sort of stage that we can understand a bit better. That's what they show right here. So, talking about multi-state binary files, they say that recent trends in cybersecurity have seen the rise of attackers using known as multi-stage binaries in their campaigns, especially malware. These attacks involve using multiple binaries responsible for different actions rather than one performing the entire attack. Usually an attack involving various binaries will look like stage 1, the dropper. The binary file used is a lightweight, basic binary responsible for actions such as enumerating the system to see if the payload will work. Once certain conditions are verified, the binary will then download the second, more malicious binary from the attacker's infrastructure. As the payload, it's like the meat and the bones of the attack. That could be, for example, ransomware. So it's a very clever way to do this. So it could be shown like this. So this is an actual diagram that show you that there's an entry point of getting your, initial file onto the victim's machine, where there's an initial dropper, let's say like a PDF file, something like that, and that can then execute something and can download something from the World Wide Web, and then in the end of the day, get the actual malware like exe files or DLL files to your machine. So it's divided into 2 stages, as you can see, stage 1 and stage 2, and this is the way it is done. Jingle.net all the way. Now, for today's task, you will be reverse engineering to .NET binaries using the Decompiler ILSpy. So we can go ahead and open the ILSpy right there. You can follow the walkthrough in the reverse engineering using the example application named demo.exe, which is the one we have into the demo folder right here. There we have it. Then we need to open the demo folder as well. There we go. So we have both the things open right now. Before analyzing the target, we need to learn and find a way to identify the original binary file, to modify it, and so on. So what we're going to do now is let's navigate to the file, the demo folder on the machine, and right-click the file and click Properties. Let's do that. Properties. And I want us to see that the type of the file is an application.exe file. That's true. Since it's a Windows file, we'll use PEStudio, a software designed to investigate potential malicious files and extract information for them without executing. This will help us focus on the static analysis side of the investigation. Let's open the PEStudio from the taskbar and then click File, Open, Select, and then open the. So one more time, ILSpy is then closed down. Let's open the PEStudio. And let's go open file, desktop, demo, and the demo.exe. There we go. And there we have it. The demo.exe is now opened. So now that this is opened right here, they talk about that the PEStudio will display information about the file, so we can start enumerating some stuff. Important aspect, from the left side there are some informations, and there are also some informations on the right side which will change accordingly to the things we do actually click on the left side. Now, they say like using the left panel we can navigate through different sections, or we'll share different types of information about the file, and the general information output displayed. When opening file, we can see that the hash of the file is in the form of SHA-256. The architecture is, in this case, is x64. The file type and signature of the language using the compiled executable is .NET using C# language. So you can see that by selecting the very first top one here to see the overall basic information about the binary file. So we can see the information is right here, .NET, executable, 64-bit, and so on. And we can also see the SHA-52 up here in the top. Alright, so let's focus on some critical data. First, we're going to identify the file and provide evidence of its alteration. We need to take note of the files SHA-256 hash as mentioned above. And we can learn more about it if we click here, but we don't do that. This section represents the memory spaces. Let's see the questions we need to answer, by the way, just to see what is the function name. Okay, once you execute what domain name, state your binaries automatically creates a zip file. Okay, so we can click this one right there because it's just to learn more about it. So we have some things we need to do before we can answer the questions. All right, so let's go back. So the section representing a memory space with different constants of Windows executable file in the PE format, we can calculate the hash of these sections in order to identify the executable. Probably we'll focus this time on 2 hashes, one from the text section and the one containing the executable code. this section is often marked as real, read, and executable. So they are actually clicking on the footprint right there, and we can see that we have some things here that are shown, and we do have the same thing. So for now, let's continue. Another essential section you can see to obtain information is under indication of strings, and there we can find the actual string that it do actually point to some local server TryHackMe connector.png. Screenshot above shows several strings in the file, like names, URL, and function names. Sure. This can be very important depending on the file execution flow. Additionally, looking for artifacts such as IP address, URLs, and crypto wallets can be a quick win for gathering some information, identifying intelligence. We'll learn about that in the next section. So far they're just showing us that we can click here on the left side and we can see different kind of informations that are interesting to us in the long run, I guess. Now that we have the information about the file, let's try to understand what the executable is doing. We need to understand the flow. We're going to try opening the file. If we try to read the file by opening it, we cannot do that since it's a binary format. In the previous section, we learned how to the file is compiled to .NET framework. So we can decompile using the ILSpy. The tool will decompile the code, providing us with readable information we can use to determine the flow execution. So let's start by opening this other application we had just before. It's down here below, ILSpy. And let's go ahead and say file, and then say open. There we go. And let's go ahead and check out what we're gonna get. Desktop, demo, and then demo.exe, and open it now. Now this can of course take some time depending on the size of the binary file. In our case it's pretty small, so no one cares. And I just tried to make the window larger. It's probably gonna happen at some point soon. Can I zoom in this? I can, just a tad, so I'm gonna do that, just a tad. So what we have here is effectively now the decompiled file. So we see this, we can click the button below, and we can see like it does say a lot of, gives us a lot of information we can look at, nothing crazy right now. So as we can observe from the above, the left panel contains the libraries used in the framework and the actual decompiled code in the section with the file name demo. We can expand it by clicking there, and then we can go ahead and click on the demo binary at the program, and then click on the main method. And now we will open the main method, where we can see that there is some sort of code here, the same URL we saw before, right? And I'm probably sure some of this will be some of the answers for TryHackMe right now. But this is just normal, C# code that will do something, download something, and when you look at this, it looks like normal, code. So anyways, let's try at the screenshot above. ILSpy can provide much information like metadata and references. However, the actual show is displayed on the bracket symbol, demo, program, and main, as they show us right here, which is actually the main function of the executable. And this is the code they show us right here. It's the code we have on the screen. So the code above displays the main function and its code. We can observe that first. It prints to the screen the message, hello TMH, demo binary, using the The method, yes. Okay, so they're explaining it to us right now. I'm going to skip that for you. Great, so now we understand the binary code. If it downloads the PNG file to the desktop, let's execute the file and see if that is true. Let's execute the file when the binary starts. Okay, so we're gonna go ahead and execute the file. I will execute the file. Hello. Enter. Bye bye. And there we have it. It's a very beautiful file we have. So we can see the name right there. It's the TMH demo. It's a paint file. It's not really call a paint file. It's a let's see what kind of file it is. Right click on it. Properties. It's a PNG file. It also said that in the code. I'm just slow today. So after executing the file, we can observe that it was downloaded to the desktop, and the messages print to the screen as expected. Also, the downloaded file is executed and opened into the default app for PNG Paint. So now that we have some practice, okay, we're gonna join McSkiddy to help investigate the alerts coming from the Where-Will apps. Put on your reverse engineering hat and help decipher the mystery behind the binary file. To answer the question, you will need to reverse Where-Will app. So all of this is something we need to do in Where-Will apps. So let's now say File, Open, the desktop and Where-Will app. Also the other one here, File, let's exit PEStudio. PEStudio and open it one more time. Yes. Now let's do File, Open, and then let's do Desktop, Where-Will app. And now we need to answer what is the function name that downloads and execute files on. To answer that question, we could probably, this is still loading. As you can see, it's blinking and doing stuff. It's usually a sign of the application is loading. We can take the other one right here, and we can see that it does have a name. It didn't delete the other part here, you know, the one part that we already have. So we can remove that I just, you know, opened. And then let's Where-Will. Let's check out what's in there. There is some fancy pancy stuff. So let's go ahead and the fancy app got nothing. The code analysis things are pretty, you know, empty. There's a form in here. It contains a lot of stuff. We can check it out, you know. It looks the program is also there. There's the main. That's probably not the right one, I guess. We're just clicking to see what we're gonna see here. We're checking out stuff. Log in stuff, override, button. Looks like, you know, a application that, you know, it's like a form of something that can, you know, I have a GUI. So let's open up the different, things we found. Not that I log in. Doesn't really say much. It's a bit slow. I'm gonna give you that. What is the function name that downloads and execute files? Okay, so download and execute. These does not download and execute anything, so we can definitely go away from that. Something called load image right there, and there's something here called well, it's just loading something, but something called download and execute file right there actually, so let's go ahead and check that out. Maybe we can just paste it in like that. That's true. So that is actually the URL. It connects to this particular domain, this port, and downloads something.exe. That's, pretty bad. Yeah. Anyways, once you execute... Whoa. Well, I'm not going to do that, but it's named explorer.exe, so we should definitely just type that in. What domain name is the one from where the file is downloaded? Do they mean this? Okay. The state 2 binary is executed automatically and creates a zip file. Compromises Victor's computer data. What is the name of that zip file? Okay, so we would definitely need to find the Explorer file then. Is that... Yeah, so visit the pictures folder. We could definitely do that. So let's go and open a file in the pictures folder. We have something called AOC. Sorry, what again? Do they want me to execute this file? I'm not really sure they want me to do that, but we want to get a hold of this Explorer files, which is in the downloads folder, it does say, but does that really mean that we have to execute this file? And is executed automatically and creates a... Well, let's just do it. I think it's pretty weird to do these kind of things, but we're doing it. So it's running and we're getting the file. The Explorer is there. It's called collected files, so we needed to do that. Let's zip. It's collected. I misspelled. So that's a crazy way of doing it. Anyways, what is that? In order to answer the last question here of the name of the T2 server, we need to go back to the understanding that we had this stage, where was it? Stage 2 part here, which is where another binary is downloaded. We saw in the source code from earlier that we will download the explorer.exe file. So what we would need effectively to do now is to open that into ILSpy. So we can click open and go into downloads and click the file explorer.exe. Now that is opened here. Let's click it and open the different kind of things. There's a program now, and we have a function called upload to file server, and we're gonna have the URL right there called anonymous c2 TryHackMe. So that is the way we can do the things in these very interesting reverse engineering programs. I think these kind of tasks are quite interesting and fun. They can provide some answers, but what you have to remember is whenever you're doing these tasks, we're not really getting the person. We're just finding the code, the responsible code behind the action, so we can see what is going on. This is just normal code. There's nothing crazy behind it. You know, everyone could create these programs. This looks like a first year graduate student program, right? Something that goes to the address, do something with web client, upload, try and catch exceptions, and what's difficult about that? So please remember, every piece of code is an instruction to computer, and it can be quite serious to just execute stuff already on a computer without knowing what you're doing. So in this room, we went through reverse engineering, and I kind of hope that you actually enjoyed it. So I would say one more thing, and that is